Next part of the lecture involves just introducing the two topics for your next homework assignment, extratropical cyclone and exercise 10A of your investigations manual. First thing they have you doing in the introduction is taking a typical low pressure system with the associated frontal boundaries and sort of filling in the missing information. So printing that off and labeling each black line as the appropriate warm front and cold front, and then the wind direction associated with each of the four sectors in this low pressure system, indicating the counterclockwise rotation and the cross isobar angle going towards the center of low pressure. See the cold front with its usual position extending down to the south of the center of the low, while the warm front typically extends out to the east. Despite the direction of the surface winds, the movement of the actual system itself, as we mentioned in lecture, is determined by the flow aloft in the middle and upper troposphere. Now, as a typical low pressure system continues to develop or intensify, the pressure in the center of it will fall or decrease, indicating the intensification of that low. If we look out here in the warm sector of the system, southeast from your center of low pressure, this southerly flow of air would be conducive for warm air advection, while back here to the northwest, this northerly flow of air would be conducive for cold air advection. Now, the maritime tropical air associated with the warm sector here in the southeast would not only be characterized by warm air advection, but would also be associated with higher dew points. And as we mentioned in lecture last week, once this system continues to progress, the cold front will eventually catch up with the warm front and develop into an occluded front, and that occlusion phase is the end of the life cycle of a low pressure system. Some of the characteristics associated with frontal passages, as we discussed in lecture. A warm front will have air temperature rising and the dew point also rising with it, while the passage of a cold front, the temperature decreases and the dew point also decreases. Wind shifts associated with the passage of a front. For a cold front, surface winds usually shift from a southerly direction to more of a west-northwest, while the passage of a warm front, we go from an easterly flow to more of a southerly flow. Next, they look at a visible satellite image associated with two areas of low pressure across the continental United States on December 14th of 2015. And overlaid with this visible satellite imagery is the position of the surface low and the respective fronts. If we were to look at this comma-shaped appearance of the low pressure over the Great Lakes region and sort of think of that as an animation, you'd see a counterclockwise swirl associated with that, indicating the circulation that we know to be associated with low pressure. In the application section, take a look at an actual surface map from October 23rd of 2015. And in this area we'll see questions with regards to looking at the position of low pressure systems and identifying the different features associated with them. The warm front extending out to the east-southeast into southern Illinois, represented by red semicircles. Cold front trailing down to the south from the center of the low pressure into northern New Mexico. If we look at the flow of air in the station models surrounding this low, we would see that it bears out the hand twist model of that counterclockwise circulation, generally going across the isobars toward the lower pressure. The change in temperature associated with each warm front, or associated with each frontal boundary, we can see here is going from Wichita back to Denver, that decrease in temperature going across the front, whereas with a warm front we see that increase in temperature as you go from ahead of the front to behind the front. The precipitation pattern associated with this is generally found north and along ahead of the warm front. So as we talked about in class, each system is different, and so completely devoid of any precipitation yet with this cold front, as we have thunderstorms developing with a little frontal wave down here in Texas and sort of taking the good return flow Gulf moisture from that cold front for the time being. Looking at the temperature pattern with the station models on this map, we can see that the radar echoes would be supportive of rain. And if we look at the isobars just ahead of the storm system or east of it, we can see 3 isobars through Minnesota, indicating a very strong pressure gradient, and would be expecting to see windy conditions associated with that. Finally, putting together that 3-dimensional picture of the atmosphere, we want to kind of take a look at the 500 millibar height contours and associated wind field and get an idea of how that might want to tend to steer the movement of surface systems. And so what it asks you to do is overlay the position of the surface low on the 500 millibar map, look at the height contours and the wind patterns at 500 millibars, and estimate the movement of that system. And so it's just barely east of this trough axis here in the western Dakotas and eastern Montana, and so that southerly flow of air on the east side of that trough axis would tend to move it in the near term towards the north. And it asks you to go back at figure 3 and look at the frontal symbols, and based on the wind pattern associated with that, we tend to expect this cold front to continue progressing sort of towards the east-southeast, while the warm front, as that low moves north, that would lift the warm front to the north-northeast. Now, if we take a look at what actually happened, you can see that it didn't take a northerly track, but it actually took a northeasterly track into Wisconsin. And so that's just goes to show you that not only is the surface system developing and evolving, but the 500 millibar surface is developing and evolving as well. And so what we find out is that the actual 500 millibar pattern that 24 hours later also changed. And so if we look at the archive from the Storm Prediction Center, we can see that this more well-pronounced trough sort of flattened out a little bit. Instead of that good southerly flow on the eastern end that we found on the eastern Dakotas, it became more of a southwesterly flow, and as a result steered that surface low into Wisconsin instead of taking that more northerly track up along the eastern border of the Dakotas.